And now we come to the third talk of this seamless session with survey talks, and it's by Silke Troemel, University of Bonn, who is leading the RealPEP group activities. And Silke, I'm looking forward to your talk. You have the word.
Thank you, Roland. Can you already see my slides?
Yes.
Okay, perfect. So good morning, everyone, again, also from my side. It's now my pleasure to shortly introduce our research group on near real-time quantitative precipitation estimation and prediction, as you heard already. So the acronym is RealPEP. And Clemens Zimmer at the beginning shortly introduced that RealPEP is funded by the German Research Foundation, DFG, and was established beginning 2019. And yeah, now after around 1.5 years of joint research, RealPEP is now organizing this conference to present first results, but for sure also to exchange with all of you, with the community, and reflect and address the state-of-the-art questions of current research on precipitation and flash flood prediction from minutes to days. So my talk gives now more a little bit an overview on the objectives and goals, and just gives some short appetizer on first preliminary results, because we will have a lot of talks during this conference from the different project scientists who talk then more specifically on their results. So these photos from Bonn-Wachtberg in Germany, that is close to where a great part of the research group is also working, are the motivation of our research group. And intense rain already resulted repeatedly in destructive floodings. I maybe want to add also, is there an option to have a... Do you see now my laser, my mouse?
I see it.
Okay, perfect. So, so intense rain already resulted repeatedly in destructive floodings of a small river. The Mehlemer Bach, this is a tributary river of the Rhine River, and all these photographs here show the same township, Bonn-Wachtberg, but during different flooding events in summer 2010, in 2013, and also 2016. And that is here the one on the right. And another flooding has also been suspected in 2018, but was then prevented with an inundation canal. So the movie here shows the reflectivity measurements from our local polarimetric X-band radar in Bonn, Boxpol, and for this event in June 2016, which we also defined as one of our case study days in RealPEP.
And
yeah.
Press the button ausblenden. Because then you don't have this, you have some Freigabe here, ausblenden, and it will be gone, just don't see it.
Okay, sorry. Yeah. Yeah, the time period between 10 a.m. and 5 p.m. is shown, zoomed in the region of interest, and the catchment of the Mehlemer Bach here is indicated in red. Mehlemer Bach is in most cases a very small, inconsiderable river which feeds into the Rhine, which is represented here in blue. And the measured estimated discharge at Niederbachem, that is here indicated in red, reaches around 40 to 50,000 liters per second compared to 120 liters during standard condition. And the ensuing animation here now shows the simulated runoff for this day in this region, starting again at 10 a.m. based on the radar data of our Bonn radar using the physics-based hydrological model PARFlow. And the color intensity in this movie indicates the strength of the runoff, so the water level. And now the additional panel shows the simulated runoff at Niederbachem reaches around 40,000 liters. This is the red line here on the right-hand panel. And the blue line represents the measurements, but the data corresponding to the overbank flow has been erased since these peak measurements are of very high uncertainty. So to sum up, the motivation of RealPEP is really the improvement of the prediction of floods, especially in small to mesoscale catchments, to mitigate risks to society and ecosystems. And the topicality is even more emphasized by the fact that the probability for flash floods will increase due to climate change. So it's now the central hypothesis of RealPEP that quantitative precipitation estimation, QPE, observational precipitation nowcasting QPN, and quantitative precipitation forecasting QPF by numerical weather prediction, and thus also flash flood prediction, FFP, can be significantly improved by exploiting the full observational state evolution information of the soil and the precipitation generating atmosphere. So RealPEP likes to achieve improvements at all stages along this process chain, illustrated here in the bottom of the slide. That is illustrated in this schematic, exploiting this observational information. And here, that is a little bit, one of the more bigger differences between Symphony, that we also put a lot of emphasis on exploiting polarimetric radar information. So research at the different stages and the integration of all the components towards a near real-time flash forecasting system is then performed within different sub-projects by different colleagues here along this process chain. And I will now go through all these projects on QPE, QPN, QPF, and so on, summarize their overarching goals, and then shortly indicate the current status. And for more details, I will then refer to the specific talks of the different project scientists. So I start with a QPE project. So we know, or it's broadly agreed that the state-of-the-art polarimetric radars enables us to estimate precipitation intensity with improved accuracy. But the respective polarimetry-based QPE algorithms, they are still experimental, so especially at C-band. And it's now our first goal to advance QPE for flat flood prediction by full exploitation of the radar polarimetry, but also by integration of the information and measurements of the commercial microwave links, the CMLs. So, and Ruyu Chen and Julius Pauls, the two are shown here on the lower right, are working in the QPE group, in our group and on the QPE topic, and they give their talks in the QPE session this afternoon. And here I just come up with short appetizers. So the radar metrologists among us know that a specific attenuation A is a very promising variable for improving precipitation estimation. And this R of A, so based on specific attenuation, A-based relation is least sensitive to rain drop size distribution variability compared to all the other radar rainfall relations. And it also includes a lot of advantages like the immunity of phase-based estimates to radar miscalibration, partial beam blockage, and especially attenuation effects. And the R of A method has been already successfully applied to S-band radars and also to our X-band radars, but the methodology has not been adapted to C-band yet. And C-band, however, is in widespread use in Europe, and also the radar network of the German Weather Service, DWD, in Germany consists of 16 operational polarimetric C-band radars. And this network is also here indicated on the right here. So we expected already some specialities at C-band based on T-matrix simulations shown on the right-hand side here. We know that the R of A relation requires much more adjustment at C-band compared to S-band, but also compared to X-band. And the scatter plot of R versus A at C-band here shown on the right, we see a very nice linear relationship for tropical rain indicated as red dots, but for intense continental rain, which is indicated by the blue dots, the R of A algorithm does not really promise an optimal relationship. And it should be complemented by a relation based on specific differential phase KDP. And KDP is also a phase-based measurement available from our radar. It's also meant to be very beneficial for QPE, especially for intense QPE. But here at C-band, in the really convective Hale cells, we have a lot of, and also along with the resonance effects at C-band, this method can result also in underestimating peak KDP values and also provide negative KDP values. And that is why Huiyuxian always also makes use of another estimate or proxy of KDP instead of using the range derivative of differential phase as an estimator for KDP. She's also using a proxy or substitute KDP estimate, which is based on the KDP set power law relation. So here comes just a scatter plot of rain rates from the operational Radulan RW product from the German Weather Service, shown on the x-axis, versus Huiyu's hybrid QPE product using specific attenuation at vertical polarization in combination with retrievals based on the standard and the proxy or so-called substitute KDP. So, well, definitely we still see quite some spread, but we also see that Huiyu's polarimetric radar-only product shows a quite good consistency with a DWD operational product, which is on the one hand side based on reflectivities only, but is also fitted to rain gauges. So Julius Polz, also working in the QPE project, is now currently exploring the dense network of commercial microwave links available in Germany for an intelligent gap filling and also for further improvements of the radar-based QPE retrievals to improve the rainfall maps wherever the radar estimates are compromised. For example, here are some examples. For example, in case of anomalous high attenuation, for example, behind hail cores, as indicated here in the animation on the left, you can see a real shadow or better, a lack of reflectivities behind this hail core moving from the west to the north here. So sure, there are also algorithms to correct for these extreme attenuation effects also, but for sure, yeah, still several uncertainties remain. And another example for some radar deficiencies is, for example, situations of beam blockage due to mountains or hill, as visible here in the right panel in the southern part. So the idea is to make use of these retrievals of commercial microwave links in these regions wherever the radar estimates are compromised. So, and now the great amount of short lines here in the left map indicate that this quite dense CML commercial microwave link network exploitable in Germany. And indeed, the bluish colors here show the 2-day accumulated rainfall between the 12th and the 14th May 2018, which is in quite good agreement with the rainfall sums from the operational Radulan RW product adapted to rain gauges from the German Weather Service, which is shown in the left panel also. And here also this animation now also shows the comparison of the hourly rainfall sums. And the agreement really demonstrates a great potential of the commercial microwave links measurements to complement and improve the radar-based rainfall fields. So more details on the QPE product, the radar, and the CML-based precipitation products follow in the talks by Huiyuxian and Julius Polz in the QPE session in the afternoon. So now I proceed with the observation-based nowcasting, QPN. So here we know information about the future precipitation development, even just minutes ahead, based on our observations, is of great value for any warnings related to precipitation and precipitation-induced hazards down the process chain, like our flash floods in the relatively small to mesoscale catchments. So the second goal is to really exploit in a synergistic way the information on convection initiation and also storm development in polarimetric radar and also in geostationary satellite observations for quantitative nowcasting of precipitation, and also to explore their value for the flood predictions in the catchments. So Ricardo Reynoso Rondinel and Cynthia Carbajal-Henken are talking in the QPE end session tomorrow morning about their work in nowcasting in real PEP. So now, just shortly some words on that already. Ricardo Reynoso exploits also the steps approach already mentioned by Uli Plahak in the talk before for nowcasting. And there are also a lot of interactions on collaborations ongoing. And you know, he mentioned already this method models the scale-dependent prediction loss in the extrapolated precipitation fields. Means as large spatial scales of precipitation are more predictable than smaller ones, STEPS aims to filter the small spatial scales of rain. And additionally, the precipitation and motion fields are both varied according to the uncertainties in the extrapolation, resulting then in an ensemble nowcast. And in this case, Ricardo uses the German-wide QPE fields generated by Huyu Chen, based here on the hybrid AUF-A, AUF-KGP algorithm generated by Huyu, and generates a nowcast ensemble of 20 members every 5 minutes for a lead time period of 2 hours with a spatial resolution of 1 × 1 kilometer. And this figure now shows an example for one of our case study days for the 19th of July 2017. And the panels A and B show the QPE fields at 17 and 1830 UTC from Huyu. And then the panel C then shows the mean of the 20 ensemble members at 1830 UTC with a lead time of 90 minutes. And then based on this ensemble, you can calculate the probability field for exceeding a certain threshold at any time. Here, the panel D shows the predicted probability field of exceeding the 1 millimeter per hour at 90 minutes lead time. Now, the next challenge we face in the QPN product is to superimpose also in the STEPS algorithms the precursory information hidden in the polarimetric radar data. And here, for sure, we think about the so-called ZER columns, the columns of enhanced differential reflectivity, ZER, which are already known as proxies of updrafts and thus also precipitation enhancement in the very near future. And for illustration here, this animation shows simulations of a storm in Villingen-Schwellingen in June 2006 with a Hebrew University cloud model, where the left panel shows the simulated vertical reflectivities, while the right panel shows the according synthetic vertical columns of differential reflectivity that a radar would see in case it's monitoring in the model. So this signature and according information for precipitation development is something we also like to exploit in the very near future for observation-based nowcasting. So now satellite data is, as I already mentioned, additionally exploited to get insights on convective initiation, means where new cells will develop during the nowcast. And currently, Cynthia Carbajal-Henken investigates the spatial variability in the high-resolved algae total column water vapor fields. You see an example field here on the left-hand side with a resolution of spatial resolution of 250 meters, and also the temporal variability in the time series of ground-based GPS observations from the dense German GNSS network. So these spatial variabilities and the temporal variabilities in the water vapor fields are then investigated or related to the MSG CVV cloud properties, as indicated here in this schematic. With that, Cynthia likes to get some insights on relationships between these variabilities and the cloud properties, which may be of use to then finally estimate the probability of convection initiation from total column water vapor fields to initiate potential new cells in the nowcasting procedures. So later on, she's heading for total column water fields retrievals from the high-resolved Meteosat third generation FGI observations. But for now, she set up already a new total column water vapor retrieval for MSG Severi, which serves as a preparatory study. The two panels here show examples of a newly developed MSG total column water vapor retrieval for two different time steps. Again, for our case study day in July 2017, together with the MSG. So these are the colors which are here, so in blue, greenish, where's my cursor, red. And this is now shown in the plots together with the cloud water path from the KNMI data set, which is more the pinkish colors. And also the circles indicate the GPS total column water vapor measurements, which are not limited to the clear sky conditions. So the MSG retrievals show relatively low precision and some problematic retrievals also near the cloud borders and for thin cirrus clouds, especially due to cloud masking issues. But as I already said, serves already as a good preparatory study for the future Meteosat third generation retrievals. Now, you will hear more details on the QPN studies also in the QPN session by Cynthia and Ricardo. But now I proceed with the quantitative precipitation forecasting, QPF, by numerical weather prediction. And here our third objective is about bridging the gap between the observation-based nowcasting and NWP. Here we'll like to explore two different pathways. The observation-based nowcast will be assimilated into NWP, but RealPEP will also extend data assimilation to satellite observations and radar polarimetry. Means the third goal of RealPEP is the exploitation of the synergy between the observation-based QPN and NWP towards seamless prediction of precipitation for forecast horizons up to 1 or 2 days, and thus improving the quantitative precipitation forecasting. So Lukas Reimann and Klaus Vorbig will report on their work in this sub-project tomorrow afternoon. And but already here, a small appetizer. Lukas Reimann is currently preparing the indirect assimilation of polarimetry via retrieved microphysical model variables. So since, for example, mixing ratios occur as prognostic variables in the model, their reliable estimation from the radar observation would allow avoiding the compute time intensive forward operators in ensemble-based data assimilation. And Lukas is currently evaluating and adjusting existing relations for liquid water content, LWC, for use with a polarimetric C-band radar network in Germany. And the different panels show now, based on distrometer measurements, comparisons of observed measured liquid water content, always shown on the x-axis, versus liquid water content estimated using his adapted polarimetric retrievals for the C-band radars in Germany. And the different panels show the results based on simulated reflectivity, based on specific attenuation, based on specific differential phase KDP, and based on a combined use of simulated reflectivity and differential reflectivity ZDR. So here, obviously, specific attenuation here in the lower right shows the best performance with the lowest RMSE and highest correlations, at least based on the DSD simulations. But Lukas will give more details on his work later on. So Klaus Vorbig, also working in the P3 project, is currently investigating the additive covariance inflation approach to improve the assimilation of reflectivity. He's working with a Kenda system using the icon model of the German Weather Service. And here remaining tasks are currently under investigation regarding the assimilation of reflectivities in situations where the model predicts the emergence of a convective cell, which is not observed in reality, or just the other way around, where the model predicts nothing, but we have some rainfall in the observations. And these discrepancies are often accompanied by small ensemble spreads with respect to the reflectivities, and therefore the ensemble Kalman filter is not able to produce adequate increments. So Klaus likes now to overcome this problem via a so-called covariance inflation for the reflectivities, where the spread of sets or the spread of the reflectivities is increased by employing a correlation between the reflectivity and the humidity QV. So the plot here shows as an example, the plot shows for 40 ensemble members simulated with ICON for the area of radar station Rostock, deviation of vertical integrated mixing ratio, QV, or specific humidity shown on the x-axis from the ensemble means versus the deviation of reflectivity set from the ensemble mean shown on the y-axis. Now I step over to project 4 on flash flood prediction, which is, as you can see again here in our schematic, placed downstream at the flowchart of this research unit, taking all the products, it's hard to see my cursor, taking all the products from the other sub-projects as input in the hydrological models. So obviously any precipitation uncertainty is propagated along the process chain to the ensuing river discharge nowcast, and RealPad likes to evaluate the value of the improved QPE, QPN, and QPF for the prediction of river discharge. So thus, the fourth objective of RealPad is to combine advanced QPE, QPN, QPF with the physics-based hydrological models. And Thomas Pomeon, here shown on the lower right, was working since recently with us, but left now. And Karina Ferrujo, here shown on the left, PI of the P4 project, will present on Wednesday morning in the flash flood prediction on their most recent results in this project. Here you just see, again, some examples, some appetizer, again referring to this flooding event of the Melemer Bach I just introduced at the beginning of my talk. They are currently assessing the benefits of radar-based QPE and QPN for flash flood prediction, taking both the uncertainty of the precipitation inputs, but also the model parameter uncertainty into account by perturbing two spatially uniform soil hydraulic parameters. And this finally results in 60 ensemble members. And the top panel here shows now the so-called poor man's or zero precipitation nowcast, means radar-based QPE is used as input, in this case, until 11:45 UTC. And afterwards, during the 3 hour of forecast of the flood events, it is assumed that no more precipitation takes place. The black curve shows again the measured discharge as a reference, but now together with the other gray curves here showing the ensemble forecast, and with the red curve showing the ensemble mean. So the poor man's nowcast is by far not reaching the observed discharge here. The panel below now shows results when QPE and nowcasted QPN by Riccardo Reynoso is used as an input, and the ensemble members here indicated with the gray curves reach the level of the observed discharge. However, they reach it too early, and in case you compare these different curves. And the reason is not clear yet. That issue is not always observed for all other events investigated. So probably the catchment just may need some further parameter tests and sets to model this slower behavior in some cases. Yeah, and finally, the fifth objective of RealPEP is now then to combine all these components from the different steps in the process chain into a near real-time flash flood forecasting system. And this is coordinated and mainly put into action by the Central Service Project, which is Eskander Hasiev in person. And to this goal, Eskander builds and maintains a data collection and exploitation platform and steers all the integration of all the new developments from the different projects into this platform. And the platform is Polara. Its name is Polara. It is a C++ processing framework developed at DWD. And during the course of the project, Eskander will continuously extend Polara, complement with the most recent components from the different stages of the process chain, and thus make them also available for all the other projects. Means we have this living flash flood forecasting system under continuous development and improvement. Yeah, and just a very rough overarching summary is that, in our first funding phase, where we are already at the moment in, RealPEP is designed to achieve improvements at all these individual stages along the process chain in QPE, QPN, QPF, and FFP, and likes to deliver the proof of concept that the assimilation of QPE and QPN in NWP leads to a smooth blending as a first step to seamless prediction from minutes to hours. But for sure, we also hope for a second funding phase to finalize a lot of remaining steps, but especially to do an in-depth evaluation of all our developments based on the investigation of larger time periods, and also to develop the individual QPE, QPN, and QPF approaches into one consistent seamless prediction ensemble from the past to the future for near real-time flash flood prediction. Thank you. Herewith, I'm at the end of my talk and happy to take any questions.
Yeah, thank you very much, Silke. At the moment, there have not been specific questions in Slido for this session yet. So I can encourage you to just type in your questions there. We are able to pick them up. I can just read them to Silke, or she can look herself directly, of course. And also you would be able to enter the speaker's room if you would make yourself known in the entrance hall or in one of your chat rooms. So it is possible to actively interact here. I have a question to start with, Silke, and I think we have Uli here as well. Clemens is there. Yes. Silke, there are different methods to do QPE and also QPN. And I wanted to ask you, what is your experience or your first idea if you, for example, take satellite data to do the retrieval like Cynthia is doing, or if you do use the polarimetric data, radar data, how large? I mean, you showed us some images, but how different are retrievals? I mean, is it? And I ask myself this for the retrieval time, but also for the nowcasting. I mean, how is the evolution of these retrievals changing between the different methods? Do you have an idea already, or is that a future?
The difference in the different, for example, QPE retrievals, also highly present on the type of precipitation you have. So there's, so it means that, so somehow the average relatively, I would say, relatively intense stratiform rain, probably these retrievals do not show too much difference, but in these extreme cases, they differ a lot, and different kind of retrievals are much more appropriate for different conditions than others. For example, for stratiform rain, which are relatively weak, so our nice German drizzle rain. So these phase-based measurements are really hard to use, and they really cannot provide good estimates because these phase measurements are just too noisy, and our weak German drizzle is nothing we have to where we have to apply these phase-based measurements. Then these phase-based measurements are really, really bad. So they just show mostly noise, right? But for these very intense and challenging, so the more intense the rainfall is, these phase-based measurements become, are much more beneficial because, they do not show too much. They have a lot of advantages and regarding this immunity to a lot of radar aspects like attenuation we have to fight with, or dependence on the DSD. All these things are, for these kind of things, the phase-based measurements show much better results and show much more reduced uncertainties. So the bottom line, it really depends on the type of rain you have.
Okay, and I guess the nowcasting side is still, it's too early for the whole project range to say more. I mean, of course, if you don't detect it properly, then the nowcasting will also be not have the best quality. But in the other cases, I mean, I just asked myself, we do now in Symphony, actually, we'll bring Uli in a moment as well. We also do life cycle development, and do you get different life cycles, and how does this compare? That would be an exciting question, of course.
Yeah, here we really face this exciting question, as I already just shortly indicated, but that is what we now just starting. How can we combine this area-wide nowcast we yield from the steps approach with some, that is a little bit a different kind of approach we are facing, at least so far in Symphony and in RealPep, that, as Uli said, they like to exploit these statistics of this parabolic behavior. And in RealPep, we want to make use mainly of these process fingerprints we have from polarimetry. Like the ZDR columns I shortly mentioned, and there are also some other stuff like signatures in the dendritic roller layer where the storm just forms, to make use of that when we see that in the polarimetric radar data. But how to combine these signatures then with these area-wide nowcasts? So that is, that will be really exciting work in the future.
Okay. Yeah, thank you. Is there any other question, any other direct question from the people in the speakers room? I look around here a little bit.
I have maybe a question to Uli. If that's possible. Uli?
Yes, please, go ahead. Is Uli there?
Yes, I can hear you, yes.
Yeah. Okay.
You could also just switch on your camera. It's nice to have, and Silke, switch off the stream, the share screen. Then we get the rest into the stream.
Yeah. Uli, it's a more technical question. We were talking already, also Roland, about the time it takes to make a forecast because of the data assimilation. Data assimilation takes time. Yeah. But there are other schemes to do data assimilation, like the one we are also using, the PDAF system, which is supposed to be much faster because it's not, theoretically not writing and reading data files. What would or by how much could you, let's say, speed up the weather forecast? So the forecast horizon, or is it of any value at all? I have no feeling for that. How important is it to make the data assimilation faster?
Uli, do you want to say something?
I mean, I cannot comment on PDAF, but generally it is of importance to make data assimilation fast, of course, because we are ingesting now much more amount of data. I mean, this radar data and satellite data, they are really dense data, and they are many. So it's important to have a fast data assimilation, of course. So at the moment we manage to make one data assimilation every hour. So if you think about, you could improve, of course, the LTKF by, or the data assimilation by cycling over half an hour or 15 minutes or something like that. But for this to work in real time, it has to be fast, of course. But I cannot comment on PDAF. I mean, at some point it must read data, right?
I can comment.
Okay.
Because the core data assimilation step altogether takes about between 3 and 5 minutes.
Okay.
So that is not, and reading of an ensemble of model states, which is some of the time, of course, is not more than 1 minute from this. So at the moment, I would say, and if PDAF, PDAF partly runs within the system, but there are other complications here, because with PDAF you have to have all ensemble members at the moment, at least, in one big process, and that is not possible to run operationally, because if one ensemble member crashes, which occasionally happens for whatever reason, the whole process would be tricky to keep. And this is why we actually really run, and we run the forward operators within the model already. This is done in other systems, in DAYS, in our data assimilation system as well. Mm. And so only the core LETKF, the ensemble Kalman filter step, needs to be run as a separate process. And actually we want to run it as a separate process for operational reasons. And okay, reading and writing might be something to work on, and I know the Japanese worked on this very hard to try to make it 30 seconds. But in principle, at the moment, I would say that's not a showstopper.
Okay.
But it's more the overall process is a showstopper. You have to wait for the data, and you have to wait like 15 minutes just to get the data available with all the conventional data if you want to put that in. And then you have to run data assimilation, then you have to run the model forecast, and that all together with writing to the databases takes you about 35, 40 minutes. And then, of course, radar data is a topic. But it is the assimilation itself is not really the problem at the moment.
Good.
It becomes a little bit one if you have a lot of radar data, but we do this super orbing as well, and we collect them and get them to the resolution of the model. Kind of the model resolution is not 1 kilometer; it's more like 5 to 10 altogether in the end. Yeah. And so you can super op data to that range, and then the amount of data gets reduced significantly. And Uli is experimenting with this, Uli's group.
Mm-hmm. Okay. Yeah.
So, yes.
Thanks you.
Further questions here? I mean, we are already entering a little bit the discussion, and I think it's good. Yeah. We have Clemens here, and we have another 20 minutes or so for that. And we also have Silke and Uli, and you are all experienced with large projects. And actually, I thought in case there are not questions coming up right from outside at the moment, which is still open, you could come. I have 2 slides with questions for you, which I quickly share for a second. Let me try that here. Discussion. Present. So the first question is, and I would have asked the same to Dave actually, but he had to go at least for this discussion session. He will be back. So it's a large group in heterogeneous group in the sense of having the QPE and the QP and the nowcasting community and now the NWP community, and then also the people doing discharge models and doing data assimilation for that with even another technical system usually. So what is Uli and Silke and Clemens? What are your experiences? How to bring people together? How to manage this? Perhaps you can give us some opinion on the challenges and on the steps you have chosen to do something here, and how to keep focus on the goals. Who wants to start? Anyone has a
yeah, maybe I can. What I can say, well, talking specifically about the RealPub group, I can say, well, maybe I think in this case, it's not so hard to keep them together and focus on the goals. Well, maybe partly because I'm happy and catch the motivated group, but I think also that is also because of more this what you show here also in the schematic and at the bottom of your slide, and what I showed also all the time during my talk. I think part of that is also because of the structure and design of the research group. That means, so we all work together on this overarching goal on the flash flood prediction system, which is also of general of relevance for society. So they all work on that, and towards this goal, everybody matters. So as you can see in the schematic, so really everybody depends on each other. So I have the feeling, based on that, it's not only me who has to motivate them, but they also take care of each other and motivate each other, because everybody wants to have the other product from his colleague and so on. I think, and especially in this kind of design of the group, it's not such a hard job. It's not only me who has to take care and motivate them.
Okay, and you do the typical thing like regular meetings.
That's for sure. That's for sure. But I don't know whether it, always depends on several things and also the people and whatever. But I also, I think compared to other groups, or maybe also, for the priority program where the overall focus is broader and the groups are more distributed over Germany. In RealPub, it's a little bit simpler because of this direct dependency on each other, and also a lot of people are working close by, so you see really each other very often. We have regular meetings, and really people know each other, doing also a lot of stuff together. I think, I think the spatial proximity is also helpful, I would say. That's maybe a little bit, a challenge we have to take right at the moment, where these socializing aspects and direct meetings are also a little bit more complicated. But for sure, this regular meeting and exchange and socializing, that is also a quite important aspect.
Okay, yes, thank you, Silke. Uli, any comment from your side? You are doing a lot of different things here, I know.
Can you hear me?
Yes.
Okay. Yeah, I mean, Silke said many important things which also apply to our Symphony project. Spatial proximity helps. We have sitting our project staff in one floor from 6 or 7 different sections at DWD, and communication is key, of course. Silke already mentioned that. So we have weekly group meetings in bigger groups, and so if I wanted to motivate everyone in the group, more than 30 people, I just couldn't. So you have to also share subgroups, responsible tasks, and so on. But a key to the thing is what Silke also mentioned is self-motivation of the involved people. And how can you give someone self-motivation if he has a clear goal, which is interesting, which is sexy, so to say, and then share also responsible to the responsibility to reach that goal in smaller subgroups, which can be dynamically formed. So a lot of the key is to have this self-motivation in the group, I think, and to allow the group to somehow organize itself in some way. But at the same time, my job is to steer these small subgroups towards a common big goal. And also helpful is for me to set some smaller sub goals, which can be tackled in different flexible subgroups. And this type of communication is key, and self-motivation of the people. Perhaps many other things, but it's hard to list all the important points.
Yeah. Clemens, you set the whole group up. I mean, you have a lot of experience with other similar heterogeneous groups, and so any comment on this? What is important points to add, or perhaps even to improve what is going on?
Yeah. I guess the most important thing is what I learned. I had far more heterogeneous groups to manage, is regular and frequent seminars.
Okay.
That is very important, so that somebody really is talking about his recent stuff and doing that in detail. That is for sure one help. The second thing is the social aspect, which has already been said, really to get the whole group together like a retreat or something like that. That I have felt was always important, also for the self-motivation, because you had the possibility as a leader to talk to everybody individually, and that sometimes helps a lot when something does not progress too much. The third thing is you really have to have all persons in your head and what they are doing, and feeling if something is not progressing as you expect, and then talk to these people, get only 2 or 3 people together, what Uli said, small groups, developing small groups, who then, to speed up the work in a region where it doesn't really get further. Or maybe you have to change something in your strategy or so. Sometimes, that means you really have to have an eye on all the people. And also, I guess it's also important for the people that they know that they are not lost. I guess these are the main points I have. Yeah. So, but regular meetings, and not only once in 3 months or something like that. Regular meetings. I would always say weekly would be best, but that's not always possible.
Yeah, that's of course a challenge if you have people sitting in different towns, isn't it?
Yeah, but it works. We have the Real PEP here, which has its regular meeting. I had this other group on data assimilation.
Yeah.
That also, we are meeting also in 2 weeks. But it's every 2 weeks. They are also distributed a lot, and I guess the techniques we have now to do these meetings online is very that has improved, and I guess that will also help a lot. We have to work more with this kind of meetings, these online meetings.
Yeah, thank you. Okay.
Yeah, maybe just one. I agree to all what Clemens said. We have in our group, we have weekly meetings where we regularly have different. We call that coffee talks. It's kind of a seminar. For me, it was very, very important that I have a very diverse group, so that people from that all people they know at least roughly what the other one is doing, and to discuss openly and to have this open air of discussion, the scientific air. That's important. And we do weekly, we do yearly retreats. The last one was last week in person under Corona conditions, so it was not easy, but it turned out that it was very, for the group, it was very necessary and very successful.
Yes.
Online meetings are okay, aren't good, but you have to have a mixture of online meeting and in-person communication.
Yeah.
So otherwise the online meetings cannot be as fruitful, I think.
Yeah.
Important point. Yeah. Any other remark on this kind of interaction? Because otherwise I would say let's take the last 10 minutes here of the discussion to look at the second slide.
Roland?
Yes.
There are two questions in Slido. One which was written to the chat during Uli's presentation, and one new one.
Okay, perhaps we take this first then. Am I online? Yes. So the first question is to Uli. The result on slide 23 is very promising. I wonder if verification has also been done with higher DBZ, something like 33 or 40. That was asked by Wang Chun.
I try to find my slide 23. You mean this?
Perhaps you can say a word here.
23, yes. I mean, I had several slides with that, but that is I can probably share it. 1 second.
Yes, go ahead. I stop presenting. Okay. Yeah.
Now you should see it.
Yes.
I just wonder if that's the correct slide. Okay, 23 should be correct. I mean, it's in that case, it's a good case, of course. You know that it was for a 25 dBc threshold on a box size of 22 kilometers. You see more problems when you start. I mean, referring to the red curves, which is the combined product. You start to see more problems for higher thresholds, of course, and for smaller box sizes, of course. And in addition to that, you see also what I mentioned on the right side, right-hand side, that it's less good for when you forecast into a growing convective situation. That is more problematic. And for this, we just have to know that it's not a skill-based method. It's a spread-based combination. It could also be that the red curve in the beginning is below the nowcasting. In some cases, when the model ensemble has not enough spread and pulls too strongly from the nowcast solution to the model, that we have seen. So yeah, you could run into these problems. So it's a promising method, but it's not guaranteed that it always works very well.
Okay, I think that should be fine for the moment, Uli.
Mm-hmm.
Thank you. And there's a second question, and that was actually to all of us, talking about the importance of goal. What are the goals for seamless forecasting? Do they emphasize continuity, avoiding jumps, versus quality at every time step? So that's of course a good question, isn't it?
Yeah.
What's the role of continuity or seamlessness versus the quality of each of the methods or combined methods? I mean, do we have I think that went to all of us, but at least here it's not said to whom, but Uli, perhaps you are just...
most didn't.
Perhaps you can say your thoughts on this question.
I mean, for me, there are different aspects which are mentioned in the question. So, of course, the first goal is to make to reduce the jumps when you fading in, fading out effects in the product. that is one goal. But that does not guarantee that if either of your two forecasting methods are wrong compared to later to the real observations which are there, then the question is how to calibrate or correct the combined products to observations. That is probably a second step. We are looking currently into this by artificial intelligence methods, neural networks, to train on the past, but that has also drawbacks, of course. But for me, these are two aspects. First, having the combined products and reducing jumps in during the forecast from one method to the other, fading in, fading outs, for example. And the second is to adjust the methods itself to the observations. I mean, in a way, we do that for the nowcasting is trained or calibrated with observations. Calibrated is the wrong word. Trained or tuned. The model also. So you should think if you combine both, then it should also deviate not too much. Yeah, it will, but if the model has a bad hair day, it will. But so two aspects.
Okay. Any other comment by Silke or Clemens on this at the moment? Or?
Hard to say. I guess for the customer, of course, jumps are not nice.
Right.
They start not to believe in the forecast. On the other hand, the jumps are also a manifestation of uncertainty. And we have to accept that. And I guess we just have to sell it in the right way. These jumps must be, on the other hand, if you say, to avoid jumps, the philosophy would be, or what is the motivation to avoid jumps? If you say, okay, if I made a forecast, there is some value in the older forecast, and I should somehow help use that to avoid jumps. That's what Uli said, to do some tuning or so, yeah. I guess it's, I would say, better accept the jumps and say what's behind it.
Perhaps I can make one comment on jumps. I mean, there are jumps within one forecast by merging different systems.
Yeah.
But there are also jumps by going from one forecast to another one, or getting a new forecast in.
Yeah.
A week ago, for example, we had a rain forecast for a Monday for several days in our global system, or global mesoscale combined system. And on Monday morning, there was no rain forecast at all for the day. So it moved over the weekend, and our systems moved. And of course, at some point, they will show a jump just by moving from one forecast to the other.
Yeah.
And it's coming from new data. It's not only new. There's a large uncertainty in the whole system, and you get new data in, and it corrects it, and that's not always continuous.
Yeah.
Yeah. Okay. So we are nearly done, and perhaps I should leave my slide to the final discussion with the questions, which will come on Wednesday. I have a slide on the overall setup and putting all this together. But I think our time is up here. We have 12:10, and that was, I think, planned to be the end of this short moderated discussion.
Yeah.
So we should go into a lunch break now, and the idea is to be back here at 1:45, so 1:45 Central European time, with Alexander Ryzhkov keynote, and then with a number of contributed talks, which are all very exciting. Actually, I can only recommend to look at them and to look at the continuation of the discussion, including Dave on Wednesday, and bringing in all the other people in all the groups step by step, with much more people in the speakers room then, I guess. And we will also send around again some information on Slido, because it's really nice if you would use it, even if just questions come when you look back to the talks and you think this wasn't answered to my opinion. It just helps to shape the discussion and the further work as well. So for the moment, I thank the speakers again of this morning, Silke and Uli, many thanks, and Clemens for your introduction and contributions. And enjoy your lunch, and we see you back in 1.5 hours here on the channel. And also please try out coffee rooms to meet some other people, or come to the entrance hall and see who is there. And we have all these opportunities to meet online, to have smaller discussions nearby. And it would be nice to at least get, if you get 2 or 3 contacts out of this meeting where you said, I met someone I haven't met before, I think then it is a success for you and for us as well. And we had a lot of people showing a lot of interest in this. So I guess that there were 100 people taking part of looking at Slido, but they didn't put questions in, most of them. So there's still a way to improve. So thank you, enjoy your food, and see you later again.